Good evening friends. I hope you are following the thermodynamic video lectures thoroughly. Today our goal is to learn about the refrigerator. So previous lecture we discussed about the heat engine. So now we are entering into the refrigerator. Refrigerator also it is a device which work in the reverse direction of a heat engine. So what are the essential parts of the refrigerator means as identical to the heat engine. Heat engine, what are the essential parts? It is having the essential parts are the, so in the essential parts of refrigerator or first one is the source, second one is the working substance, third one is the sink. So to learn about the source, sink, working substance and sink, I am not explaining here because of I already explained in the heat engine. So you go through this that video lectures, you can easily understand. Now I am directly entering into the what is the working process or working principle of the heat engine. So working principle of refrigerator. Now let me as the definition of the refrigerator, a engine, a device which can work in the reverse direction of the heat engine, that engine is called as a refrigerator. Now we will have a high temperature source. So it is having high temperature T1, we have a working substance and also we have a low temperature sink. We have a low temperature of sink. So as it is working in the reverse direction, in the previous case heat engine will absorb the Q1 amount of heat energy. So now I am drawing here the heat engine diagram. So the Q1 amount of heat energy is taken from the source, it will do some work W. The Q2 amount of heat is released to the sink. It is the source, it is the sink. About the heat engine, these are the heat engine. But as it is working in the reverse case, the Q2 amount of heat can be taken from the sink by the working substance. To take this amount of heat energy, we need to do some work on the working substance, we need to perform a work on the working substance. Then this amount the amount of heat must be sent to the Q1 amount of heat must be sent to the source. But one thing you need to understand here, it is not possible by itself of the refrigerator so it cannot be taken directly from the source of Q2 amount of heat, because of we must perform some external device is there that may be called it as the compressor in the refrigerator. That means one of the part is working on the working substance which can drag the sum of the heat energy which is consisting of a low temperature part. That sum of the work, the amount of energy it is released to the source, that releasing heat energy is called as the Q1. So that means here the essential part is some of the external device must be essential in the refrigerator to perform these to drag the low temperature heat energy and send to the high temperature part of the sink. That is the very important. In the previous case the heat engine is defined the thermal efficiency of the heat engine. Here also the coefficient of the performance, the refrigerator can be defined as the coefficient of the performance of the refrigerator. Coefficient of performance. So it will denoted with the COP. So they will call it as the coefficient of performance of the refrigerator. So the formula for the coefficient of the performance of the refrigerator will denoted with the beta is equal to heat extract from sink divided by work done. This is the formula we are having. How much amount of heat extracted here? Q2 amount of heat extracted. How much work is done here? So the Q1 minus Q2 amount of work is done here. So then this formula can be written as T2 divided by T1 minus T2. This formula is the formula for the coefficient of the thermal coefficient of the performance of the refrigerator. So I hope you understand about this refrigerator. Now these formulas are very important. We need to use to solve the problems. Now what is the perfect refrigerator? A perfect refrigerator means perfect refrigerator. So what does that mean by perfect refrigerator? Means without any work the refrigerator can extract the heat energy from the sink to, and it must be sent to the source. So that means we should not do any external work. External work is equal to 0. Then formula beta is equal to, what can we write? Q2 divided by Q1 minus Q2 is there. Then work is equal to 0. This value is equal to 0. Then Q2 divided by 0, that is equal to infinity. That means a perfect refrigerator, the coefficient of performance of the refrigerator value is equal to infinity. They are asking in our competitive exam, beta is equal to infinity for the perfect refrigerator beta value. So I hope you are following the lecture. If you are feeling that these lectures are useful for your preparation, then I am requesting you, please subscribe our channel, which can be support our channel. Thank you for listening.